Hi, I'm Guiller Angelo Hermoso and I'll be discussing integration.
He doesn't know much about this kind of stuff, but he will still explain.
Integration is the inverse of differentiation. These two concepts are linked and work hand in hand to solve various mathematical problems. Differentiation breaks down a function into parts, while integration combines those parts to reconstruct the original function. In geometry, we learned how to find the area of different shapes and polygons, but it gets a little bit tricky when a curved edge is involved. For example, we have this adilocate shape and we were tasked to take its area. We know that there is no formula that will give us the exact area of this shape, unlike other shapes, but we can approximate it using the shape we know how to get the area of, a rectangle. Now, I will be introducing to you the Riemann sum. Riemann sum is a method used to approximate the area under a curve by dividing the region into smaller rectangles. It provides an approximation of the total area between the curve and the x-axis over the given interval. Let's learn how to compute integrals using Riemann sums. With this given curve and interval, we will divide it into several subintervals, forming regular partitions. We will calculate the net area of the rectangles to take the approximation of the area under the curve. We can use the summation notation to represent the sum of their areas. The f of x sub I is the height of each rectangle, and the delta x is the varying width of each rectangle. To find the delta x, we will use this formula, b minus a over n, where b is equals to 8, a is equals to 0, and n is the number of rectangles. This gives us a value of 1. To find the height of a specific rectangle, we have to find the limit of the function as x approaches the specified endpoint. 1 times 1 is equals to 1 square unit. 1 times 2.68 is equal to 2.68 square units, and so on. We will now take the net area of this graph, which will give us an area of 9.28 square units. What we have done is what we call the left Riemann sum, and we find it using graphs. We can do better approximation by using the right Riemann sum, and we will be using tables to find it. Let's approximate the area between the x-axis and the function from x equals 0 and x equals 8 with 4 subdivisions. Given that our subdivision is 4, our delta x would be 2. Since we are taking the right Riemann sum, we will consider the 4 values from the right. By multiplying the f of x with the delta x, we will get an approximation of 11.44 square units. We can take the average of these areas to get the approximation of the area of this graph, which gives us an answer of 10.36 square units. To get more accurate answer, we need to use the more rectangles for approximation, but it could take much time for us to get real area under the curve. For us to get the exact area of this graph, we can use this formula where the weird S symbol is the symbol of integral, or the limit of sums. F of x as the function being integrated, or the integral, and a as the lower limit and b as the upper limit. The symbol dx is required for integration, but it has no meaning by itself. We will not yet talk about how to use this formula, but for now, let's just plug in our values and evaluate to get the exact area of our curve, which is 10.29 square units. And that is our basic introduction to integration, approximating areas under the curve. Thanks for watching, guys. Please like this video and subscribe to my channel for your support.